Good day, my dear students, and welcome back here in our science class. And for today's video, I'll be discussing stoichiometry mass relationship. So let's have a little review. So when you say stoichio, it means Greek for element, and when you say metry, it means measurement. So when you combine them, definitely stoichiometry is about measuring the amounts of elements and compounds involved in a reaction. So consider the chemical equation. We have here 4 ammonium plus 5 dioxide used to react 6 water plus 4 nitrogen oxide. So there are several numbers involved. Okay? Now, what do they all mean? Now, using these chemical equations that was been given here, we're going to recall that chemical formula represent numbers of atoms. So the representation here of the number of atoms, here are the subscript. So we have here the 3, the 2, and then another 2 here for the water, and the rest, those elements that has no subscript, it means they are indivisible one. Okay? For example, in ammonium or NH3, we have 1 nitrogen and 3 hydrogen atoms. For dioxide, we have 2 oxygen atoms. For water, 2 hydrogen atoms and 1 oxygen atom. And then for nitrogen oxide, we have 1 nitrogen atom and 1 oxygen atoms. Now, another thing here is you can see we have here a coefficient. So we call this as moles. So these chemical formulas are balanced with coefficients. So what we have here is when you have this kind of coefficient, we definitely multiply. So for example, 4 times 1, that will be 4 nitrogen, and then 4 times 3, that will be 12 hydrogen. Same thing, if we multiply 5 times 2, we got 10 oxygen. And then if we have 6 here, we multiply it, we got 12 hydrogen. And then again, our oxygen here has an indivisible one. We multiply it, 6 times 1, we got 6 oxygen. Nitrogen oxide, indivisible 1, so 4 times 1, that will be 4. Plus, we have here another 4 oxygen, 4 times 1, that will be 4. Now, with this stoichiometry, we found out that those coefficient of 4, 5, 6, and 4 do more than just multiply atoms, but also they can mean either 4 molecules of NH3 react with 5 molecules of dioxide to produce 6 molecules of water and 4 molecules of nitrogen oxide. To simplify this, we can say that 4 moles of NH3 react with 5 moles of dioxide to produce 6 moles of water and 4 moles of nitrogen oxide. It means that when you have 4 molecules or 4 moles, it is represented as 4 ammonium. Okay? Same things goes to dioxide. If you have 5 moles of dioxide, so the representation here, we got 5O2, like this. Also for 6 moles of water, it means it has a 6 molecules of water, and also for nitrogen oxide, so it has a 4 molecules of nitrogen oxide. Now, this coefficient or the moles, we can call it as the mole ratio. So if you are going to identify the ratio of a certain chemical equation, so you may refer simply on their coefficient. Now, let's try to apply this equation to a problem. For example, how many moles of water are produced if 2 moles of dioxide are used? So the first thing you're going to do is you write the given. So you have a 2 moles of dioxide, followed by, for us to able to cancel out the mole of O2 because we are looking for the moles of water, so we get the coefficient of 5 mole of dioxide and 6 mole of water. There, as you can see, we're going to cancel out the mole of dioxide, and what will be left here will be the mole of H2O. So now, the next thing you're going to do is you are going to divide 6 divided by 5, and when you multiply it by 2, this will give you an answer of 2.4 mole of water. If you're going to observe, you will notice that a correct balance equation is essential to get the right answer. Let's try this again. If we have an example like here, that how many moles of nitrogen oxide are produced in the reaction if 15 mole of water are also produced. So again, we're going to write the given 15 mole of water, and for us to able to cancel out the mole of water, we need to get the coefficient of the water. So we got here the 6 mole of water, and then in our numerator will the 4 mole of nitrogen oxide, because again we're looking for the moles of nitrogen oxide. So we have to cancel it out. So the unit will be left here will be the mole of nitrogen oxide. So same thing process again. We will divide 4 divided by 6, and then you multiply it by 15. Then here it will give you an answer of 10 mole of nitrogen oxide. Now, let us recall by getting the chemical formula of the molar masses. How do we usually get the molar masses of each compound? So you need to look on your periodic table and get their atomic mass unit. Let us try to solve first the NH3. Since we got here the nitrogen and hydrogen, so first let us get the atomic mass unit of nitrogen. So nitrogen here is 14. So we write here 14, and then we multiply it by 1. Why? Because again, nitrogen has a subscript of 1 here. Next, we get the molar mass of hydrogen. So we got 1. So with that, we write here 1, and then we multiply it by 3 because that is the number of atoms of hydrogen presented in here. So there, we just simply multiply 14 times 1, that will be 14, and then 1 times 3, that will be 3. The next thing you're going to do here is you're going to add 14 plus 3. This will give you a 17 grams per mole, and this will be the molar mass of NH3 or ammonium. Let's try this again for dioxide. So going back here in our periodic table, oxygen has a 15.99 as its atomic mass unit. So we're going to round it off, will become 16. So write 16 here, and then you multiply it by 2 because that is the number of atoms presented in oxygen. So 16 times 2, that will be 32 grams per mole. Next, for water, you write here again the elements. So for water, it has an atomic mass unit of 1, and then for oxygen, we got 16. So you multiply the atomic mass unit to the number of atoms or the subscript of a certain element. So since hydrogen has 2 atoms, you multiply it by 2. And then for 16, since it has a indivisible by 1, then you multiply it by 1. So there, 1 times 2, that will be 2, and then 16 times 1, that will be 16. Then you add it. So 16 plus 2, this will give you a 18 grams per mole. Next, for nitrogen, since the atomic mass unit of nitrogen is 14, and then for oxygen, the atomic mass unit is 16. Again, we're going to multiply it based on the number of atoms presented on each element. So nitrogen has a 1 atom and oxygen has 1 atom. So we will multiply it by 1. So 14 times 1, that will be 14. 16 times 1, that will be 16. And with this, we're going to add it. This will give us a 30 grams per mole. And that's how you get the molar masses of each compound. Now, let us try if we're going to look for the grams. So we have here how many grams of water are produced if 2.2 mole of ammonium are combined with excess oxygen. Our main goal here is to find the grams of water. How many grams of water? So first, if you have 2.2 mole of NH3, again, you're going to write it, 2.2 mole of NH3, and then for us to able to cancel it, we're going to locate here in our chemical equation up here. So we write 6 mole of water over 4 mole of NH3. So again, we cancel out the units. And what we have here is the mole of water. We're going to divide it, 6 divided by 4, and then we're going to multiply it by 2.2. Now, that won't be the final answer. Since we're looking for the grams, so what we're going to do here is we will get the molar mass of water. So for us to able to get the grams of water, we'll cancel out the unit of water to 1 mole of water, like this. And then we're going to multiply it by 18.02 grams. So a while ago, we got a molar mass of water as 18 grams per mole. It means that water has a 18 grams in every 1 mole. Okay, so again, after dividing it and multiplying to 2.2, we're going to multiply it to 18.02 grams of water, and there this will give an answer of 59 grams of water. Let's try this again in another problem. How many grams of dioxide are required to produce 0.3 mole of water? So first, you write the given 0.3 mole of water, and then we'll be focusing on the equation here. So for us to be able to cancel out the mole of water, we write here 5 mole of O2 over 6 mole of water. So there we cancel out the units. Now, since we'll be looking for the grams of O2, we need to write here the molar masses of dioxide. So we got 32 grams of dioxide. So again, we divide 5 divided by 6, and then you multiply it by 0.3, then you multiply to 32. This will give an answer of 8 grams of dioxide. Now, in this problem, if we're going to observe, It says here that how many grams of nitrogen oxide are produced if 12 grams of dioxide is combined with excess ammonia. The value that was been given here is 12 grams of O2. So first thing you're going to do is to convert this 12 grams of O2 into a moles. 12 grams of O2. So we got 1 mole of dioxide over 32 grams of O2. So for us to be able to get the mole, so again we cancel out the units of grams of O2, and then we will multiply 12 to 1. So that will be 12 divided by 32. Right after that, we'll be going to proceed again what we just did in our previous examples. So you're going to write here 4 moles of nitrogen oxide over 5 moles of O2. So we cancel out the unit of mole of O2. And then right after that, we get the molar mass of nitrogen oxide. So there again, you divide 12 over 32, and then you multiply on the quotient of 4 over 5, and then you multiply to 30.01 grams of nitrogen oxide to give you an answer of 9 grams of nitrogen oxide. Now, moving along the stoichiometry path, we always use the same type of information to make the jumps between steps. So, grams to moles, then moles to grams. So, molar mass of X and mole ratio from balance equation and molar mass of Y. So in here, we can start anywhere along this path depending on the question we want to answer. Notice that we can directly convert from grams of one compound to grams of another. Instead, we have to go through moles. As a guide here, always remember and take note of this, we are going to convert mass to moles. From moles to mass, we cancel out the grams, and this will give you the value for the unit of moles. And with that, this will be the end of this session. Thank you so much and see you on the next video.